Domain and range. Domain is all the x values, right? And if you write a domain, that is in interval notation. So you have parentheses and you have brackets, right? Okay. And if you remember or if you understand functions, and in particular, there's what's called 6 basic functions, which happen to be a linear, quadratic, cubic, square root, inverse, and absolute value. Those 6 basic functions, if you understand the characteristics of those, then you should be solid when you're talking about domain and range. Okay, so I can send you a PDF. Matter of fact, I'll put it up on the website. It says 6 basic functions. It's about 2 or 3 pages, but it goes through every basic function, and it tells you every characteristic. Increasing, decreasing, max, mins, end behaviors, zeros, x-intercept, y-intercepts, domain, range. It covers everything. And it lists them out, and you can see it drawn. Because it's basically parent functions of everything. So, all right. If you're looking at a domain of a radical, then you're going to set it, the radicand, which is everything underneath the radical, to greater than or equals 0 and solve. And then you'll have the domain for that. So that's what it's saying down here. If there's a denominator in the functions formula, or if it contains an even root, set the radicand greater than or equal to 0, then solve. So some things in there. We'll go through that. Set builder or set notation. We've done that. Interval notation. We've looked at that, have we not? It's kind of putting the cart in front of the horse. We've already done this, right? We just got done doing this. And then they talk about it in the next section. It's kind of backwards. But anyway. Intervals, they're talking about open dot, closed dots. Unions, right? To combine all intervals in one set, which is an OR. Anything there? Piecewise functions. Hey, we talked about them the other night, did we not? We did. We said y'all used piecewise functions before in your life, have we not? You have where? Huh? Yeah, price breaks. Mailing letters or mailing a package, right? If it weighs a certain weight, you pay more, but there's a range of things that cost there. Piecewise functions, they're not as scary as what you think they are. They're worse. So no, they're really not. They're quite easy. But the key is looking at from where to where on the domain are we looking at this particular function. So we'll keep it to like linears and quadratics and stuff like that. So, and we'll look at how piecewise functions are sketched. So we'll look at that too. Okay, so if we look at this one, it says for the given relation, and the relation is a set of ordered pairs, right? Give the domain and range and indicate whether it is a function. Well, first off, in order to tell whether it's a function, our x's cannot repeat, right? So I got a 1, I got an 8, got a 9, and got a 3. I'm good. This baby is a function, right? So if I do the domain, does it matter if it's in order? Nah. We tend to put things in order. That's how we've been trained. Range, we have a 2, a 3, a 5, and a what? 7. So as long as you got all those there, then we're good, right? Okay, any questions on that one? Y'all really good on that? Sweet. Yep, domains are the x's and the range is the y's. Yep. Okay, so let's look at this one because I could have picked a a slew of examples to use, but I thought we'd look at some that were at least useful on some things and allow you to look at different stuff. Find the domain and range of the function below using interval notation. Well, first off, does this function go on forever? How do you know? You have closed dots there, right? There's a finite ending point on that. So if I'm looking at domain, which is x values, right, then I'm basically only looking from here to there, from 1 to 7, right? Now, does it include 1? Yes or no? Yeah? Okay. So domain 1 to 7 includes 1, and it also includes what? 7. What always gets parentheses no matter what? Not closed dots. Open dots and infinities, negative or positive, right? Yeah. So those are guaranteed to have parentheses. Now, I'm going to tell you 2 questions that you can ask yourself when it comes to finding the domain. That if you'll ask yourself this, you'll be okay. And the question is, how far to the left does it go? That's the first question. Because the domain in interval notation, it's always written smallest comma largest, always. So it's never largest, smallest. It's smallest comma largest. So if you ask yourself, how far to the left does it go? Well, it goes to who? 1. How far to the right does it go? It goes to just 7. Those are called leading questions. So if you ask leading questions like that on the domain, what do you think we'll ask for the range? Yeah. How low does it go? -3. If you were to give that ordered pair, would it be there? Is that a point on the graph? Is -3 a point? Yes, ma'am. So therefore, I would. Now, so how high does it go? 6. Is 6 included? Yeah. Okay. Questions? Yeah. A parentheses? The parentheses will always be on infinity, positive or negative, and it will always be on open dots. Okay, always on open dots. All right, so let's look at this one. Does this go off the graph towards right? Okay, it does. There's no ending point, so therefore we have to assume that it goes on forever. Right? So, how far to the left does it go for domain? That's right. -1, right? How far does it go right? Forever. What's forever? Infinity. That's right. Exactly right. There you go. Now let's look at range. How low does it go? Look at that. Man, y'all going to be rock and rolling on this section. How high does it go? How high? Are you sure? I'm hearing infinity. I'm hearing 8. Are you sure? It's infinity. I'm just talking you out of it by looking at you. Don't let me do that. You need to be confident in your answer. Okay? Stay true, even if it's wrong. And if it's wrong, then we'll discuss it, why it's wrong. But if I can talk you out by looking at you, going, then you ain't set on whether that is what it needs to be. Know what you know what you don't know, and get your unknowns known. Have a reason why you said it was infinity. All right. We had this discussion earlier. 9 minus 3x is the radicand, right? That's everything under the radical. And it's an even root. How do I know it's an even root? It's a square root. The index or the root is an even number, right? So 2, 4, 6, 8. You can do this on. Okay? So they will always be greater than or equal to 0. Because if you look at the parent function for a square root, you're looking at 0 to infinity for the domain. Okay, from 0 to infinity. So it would be greater than or equal to 0. Now, so you don't have to worry about shifts and all that other stuff. You just take the radicand, set it greater than or equal to 0, and then solve it. No, ma'am, you don't worry about the 3. What does the 3 do? Amen. It gets in the way. That's exactly right. What is the 3, y'all? Because we're going to talk about shifts. That's a vertical shift, is it not? Think about what we're doing. We're taking some answer, and then, well, 3 minus that, right? If you flip that, put that at the end, it would be the negative 1 times square root of 9 minus 3x plus 3, right? But they normally don't put things like that on the end of radicals. Why? Anybody know why? They normally end radicals in the equation and never put anything behind it because you don't want to be mistaken whether that's part of the radicand or not. Anything that's happening needs to go in front. That way you know it's not underneath the radical, right? Yeah. Where did I get that greater than or equal to? Okay. So, here we go. If I look at the square root function, this is what it looks like. Okay, that's the parent function, square root. It starts at 0. Its domain is 0 to infinity, right? So as long as I take any radical, even root, okay, square root, 4th root, 6th root, 8th root, I will always set it greater than or equal to 0 because they do not exist for negative values. You cannot take the square root of a negative number or the 4th root of a negative number, 6th or 8th root, because those are imaginary, right? Y'all remember when we done those? Yeah. So that's why we're setting it greater than or equal to 0. So we'll go minus 9. So we got negative 3 greater than or equal to negative 9. Watch this, because this is going to get you. I am dividing both sides by negative 3. So ladies and gentlemen, what does it do to my inequality? It flips it. Negative 9, negative 3 gives me positive 3. So ladies and gentlemen, I'm basically looking at this and I'm going which way? Y'all agree? Well, it needs to be a solid, right? If I'm graphing on number line, if I take that inequality and graph it, this is what it should look like. Y'all agree or disagree? Okay, so what would I put for its domain? Yay or nay? Don't shrug them shoulders. Lord, have mercy. I'm not ignoring the graph, am I? Which graph? Well, let me ask you. So what graph are you talking about? The one in green and purple or the one in black? The green and purple only tells me why I'm setting that radicand greater than or equal to 0. So that's the math theory behind it. Okay? The black one is graphing the solution. So theory, uh-oh. That's theory. That's why this right here happens. Okay? That's what allows us to say that. So, all right. I know this is underneath in the denominator. I'm very much aware of that. But it don't matter. We're still going to do the same thing. So what is the domain of this? Minus 1. X has to be greater than or equal to what? Negative 1, right? Because the smallest number that it can be underneath that radical would be 0. If you take square root of 0, you get 0. Right?
Can you explain the greater than or equal to on that again? So, why is that?
Why is this greater than or equal to?
Yeah, why is it true? Oh, okay.
Because of the parent square root function domain.
Will it always be
180%. All right, so that's why. But we're going to have a discussion. Because this says x has to be greater than or equal to negative 1, right? Correct? But if I plug negative 1 in there, what'd I get? 0, okay. And what's the square root of 0? No. So basically, they're saying based off this, it's to there, right? Y'all agree? But mathematically, I say this. Why? Hmm? Yeah. Now, so I'm curious on how they're going to take this in the computer. If they're going to account for that restriction or not in the domain. Okay? If they don't account for it in the domain, then you're good with the bracket, right? But they should. Does that make sense why they should? That's right. But look where this square root is. It's down in the what? No, it's down in the denominator. And you got a variable in the denominator. Anytime you have a variable in the denominator, you know that there's restrictions, right? Places that are going to cause it not to exist. Negative 1 would make it not exist because square root of 0, that's 0 in the denominator. How can you have, what's the numerator? How can you have 9 parts and nothing? Can you have 9 parts and nothing? Oh, yeah. Yeah. You can't have it, right? It doesn't exist. So if it doesn't exist, then it's undefined. So mathematically, the purple is correct. Do you understand me? And do you understand why? No? Well, I didn't try the homework on this. Okay? So I didn't go and see whether they were. I know the purple is 100% correct. Because mathematically that is sound. Okay? But my question that I don't know is, are they taking in account the restriction when they're looking at this domain or not in their answer. Does that make sense? Well, the only difference between it is a bracket and a what? Yeah, I don't know whether that's going to be a bracket, you know. Huh? This one? Parentheses. So they are including that in the. So I want you to be aware of that. Does that make sense? We would technically go here because if it was in the numerator, hey, it's going to take a bracket, right? But because it's in the denominator, then that's mathematically 100% sound. So make sure that you understand that. I don't know if I've done any good or if I've done more harm. So that's out. Y'all understand why that's out? Because we have a denominator. It's in the denominator, right? So there is a restriction. So it can't be -1, right? That's why it went from a bracket to a what? Let's see.
Okay, that's what I was curious on. I was like, what? But I see that.
I just didn't know how they were handling it in the homework. That's the question I didn't know. But they should have handled it like the purple, and she said that they did. Yes. What do you mean now? Why did we not flip the inequality on this one? Did we multiply or divide across it with a negative? No. That's the only time it would move or flip, okay? All right. Woo, Lord help me. All right, so this is pretty cool. You ready? It is. I promise you. Well, let's just look at it like this. X squared plus 6x plus 8. That's what type of equation? A quadratic. Yeah. And I'm starting to agree with Riggett. We had a discussion. Praying for, right? Yeah. All right, good. So let's just factor this, okay? We ought to be able to factor these. So A times C is 1 times 8 is 8. And then, so what are factors when multiplied will give me 6? No, will give me 8, but add together to give me 6. That's what? 4 and 2. So I have x plus 4 and x plus what? So I set them, so that's each one equal to 0. So x is -4 and x is negative what? 2. All right. Now, let's just hang on right there. Put a big old pause. A quadratic looks like a U. And its domain is from -infinity to positive infinity. Always, right? Why? It's like this. But it never comes back in. Does that make sense? It can be really steep or it can be wider. Right? So they do it every Friday, Saturday, Sunday in the fall. Whoa, quadratic! So listen to them. They're not saying touchdown. Read the lips. It's quadratic. So anyway, that's what it is. You won't ever look at a touchdown ever the same again. That's right. So there. So that, and this is what I talk about, those 6 basic functions. Those are characteristics. The domain of quadratics all the way from negative infinity to positive infinity, period. So we know that. But look where our quadratic is. Where is it? Denominator. So we got some restrictions, right? It can't equal who? It can't equal who? Right? It can't equal -4 or negative what? It can't equal them, right? So how the heck do we write that? Well, we're going to go negative infinity to negative 4, parentheses, right? Or negative 4 to negative what? 2. Or negative 2 to what? Infinity. So it can't equal these. It can't equal those. Because those are what makes it 0, right? And if you have 0 in the denominator, then you have an undefined situation. So that's a place where it doesn't exist, right? Yeah? Now. You want to nerd out for a second? Can we nerd out for a second? I'll show you something. Okay, so. Dad, turn it. Clear. So what was the numerator? 1 divided by, divided by open parentheses, that's x squared, right? Plus 6x plus who? 8. All right. Y'all ready? Graph. Zoom 6. See those asymptotes? Guess where those asymptotes are? Negative 4 and where? Yeah, because it doesn't exist there, right? Asymptotes are lines that the function approaches but never touches, right? Does that make sense? So you could clearly see that, hey, it's going up, then it crosses over, then it's what? Back down, and then it's what? Does it again. So that's why I like the math modeling 1101, because you get to see things like that. And sometimes seeing is believing. Fair enough? Okay. Yeah, I'm going to use parentheses. Why? Nope. That computer give you brackets too. Why am I using parentheses for negative 4 and negative 2, guys? That's exactly right. See, if this thing was in the numerator, shoot, we'd be using brackets, right? Well, really, we wouldn't even be saying any restrictions, would we? We'd say negative infinity to positive infinity. Every x you ever choose will work, right? But when you put it in the denominator, then they just mess it all up for you. Yeah. Okay? All right, here we go. So we're going to piecewise, right? So here's the piecewise function. The first one is x squared minus 1. That's a quadratic. It's only good for values. This first one is only good for values from negative infinity up to 2 and including 2, right? And then the x minus, or negative x plus 2, which is a linear equation, it's only valid from 2, not including 2, and up, right? So you'd have a solid on this yellow equation with an open dot on the linear one, right? Y'all agree? All right, let's see if we can't do this. Is that going to bother y'all? It's 75 degrees in here. Yay or nay? Just imagine yourself on a Twin Props, taking a flight. You'll be asleep in a little bit. All right. All right. So for the function defined here, find f of 0, f of 2, and f of 4. Well, first off, what you have to make sure you understand is, where does 0, 2, and 4, what equation does 0, 2, and 4 fall into, right? Where in the domain do they belong? Well, where does 0 belong? In the yellow or the blue? Which one? Oh, we're going to sweat. I can't hear you. Sorry. All I hear is humming. I'm halfway deaf anyway, so sorry. All right, so where's 0? Is it in yellow or blue? Are you sure? There you go. Yeah, because I told you that your domain for the first one was negative infinity all the way up to who? 2 and including 2, right? So if we kind of think of it like this, hey, this joker right here, it's like negative infinity all the way to 2, right? And that this one is 2 to where? Infinity, right? So if I write it in interval notation like that, then it's a little bit clearer to where things go, right? The 0 and the 2 go in the first one, and the 4 goes in the second one. So I don't even have to calculate anything. At 0, what is my answer? What's f of 0? Negative 1. What's f of 2? Well, that's when x is what? 2. That's what? It's this one, right? Don't pick open dot, because open dot means it does not what? Exist there. What is f of 4? Go to 4, boom, there you go. That's what? Negative 2. And that's what it's asking you to do, is it not? That's exactly right. They give you a graph, you can pull that off. Go to that value on x, look at it up or down, see where that graph is, right? Yeah. Questions? Wasn't as difficult as you thought it was going to be, right?
Right now.
Oh, come on.
Wait, why'd you do that circle as negative 4 or negative 2?
Which one? Here? This one right here?
Yeah.
Oh, I just showed where it intersected, right? At 4, boom, it's at negative 2, right?
Oh, okay.
Right.
Could I have chosen like negative 3?
No, sir. You wouldn't have chose negative 3. Why?
Oh, wait. I'm so confused.
All right. So go to 4 on the x-axis, right? Go to 4 on the x-axis.
Okay.
Now, look up.
Oh,
Do you see anything?
yeah, I see.
Now look down. Where does it intersect? Where does 4 intersect that line? It intersects it at what y value?
The negative 2.
That's exactly right.
Wait, but if you go to 5, it's negative.
Yeah. But we ain't asking for 5, right? We only asking for who?
Oh, between the.
Yeah, it said 0, 2, and what? Oh. I just wrote what the domains were.
Okay, never mind. I don't have my glasses with me, so it's hard to see.
I wouldn't even thought the glasses thing. It's okay. Yeah. Okay. So this one doesn't have a graph. So what are you going to do here? All right. So I'm going to give you, I don't know, 30 seconds. Let's see what you can do. All right, so some of the strategies are identify your domain and then see which equation to evaluate in, right? So all right, so I identified my domains, right? Kind of written those out. So let's see. I got f of negative 6, right? Well, negative 6 falls between negative infinity and 3, so I'm going to use this one. So what is, that'd be 6 plus 1, which is what? 7? How many of y'all said negative 5? Anybody? When you substitute things in, make sure that you're putting them in parentheses to keep from making that simple mistake right there. 3 would be in the top equation, so that's negative 3 plus 1, which is what? That's negative 2. And of course, the last one, which would be 6, is in the bottom one. So that's x minus 5. So that's really 6 minus 5, which is what? 1. See my domain here? It's from values greater than 3, but not including 3. So 6 is what? Greater than 3, right? So it would be in there. So that helps you. That's a strategy that will help you. Because that's really the hardest thing about a piecewise. Knowing what domain, what's the domain for each one of those little pieces. And where is the particular x value that you're trying to evaluate or analyze, where does it fit? So, all right. Any questions on that? Oh, we got to graph it. Anybody know how to graph this one? Anybody remember how to graph? Huh? Well, let's look at it. Where do I start at? I'm going to do this one in green. So I start where? -2, right? That's my y-intercept. My slope is -4/3, right? And my b, my y-intercept's -2. If you remember, that's y equals mx plus b, right? So it's negative. So what I'm going to do is I'm going to go down. It's -4/3, right? So I'm going to go down 4, 1, 2, 3, 4, and over 3, right? So 1, 2, 3, 4, and over 3. Negatives go down and to the right. Positives go up and to the right. If you go right, you'll never go wrong. Fair enough? Negatives go down and to the right. Positives go up and to the right. So, well, that's, hold up. I ain't done yet. About to show you something. This is only good up to who? -3, right? But look what, I mean, I went down, and I'm down here, right? But it doesn't even exist on this side, does it? So if I have to reverse it, what's the opposite of down and to the right? Up and to the what? To the left. So I'm going to reverse it. I'm going to go up, 1, 2, 3, 4, over 1, 2, what? 3. 1, 2, 3, 4, over 1, 2, what? 3. Now, you can't do this, but I can. That's an open dot at -3. Okay? And then I can get rid of this one, right? Or you can all right, let's just show you. It'd be a lot easier. There. I'm going to put where I'm supposed to stop at, right? Correct? Okay, so just bear with me. So I've graphed it, right? So, shoot. It's not going to exist right there, is it? Why? Because it stops at what? -3, right? Okay. So, I went down and right because the slope was negative, and then I looked at my domain restriction, and it wasn't even there because it stopped at -3, right?
So you had to go back up.
Yeah, I had to go back up and over, yeah. If I'd have thought about it, then that's what I'd done. But so let's do that. That's -1, right? And we're going to go down 1 and over how many? Mm-hmm. So down 1 over 3, right? 1, 2, 3, there. And then we'll go up 1 and over what? 1, 2, what? 3. And you got to do this with a computer. How is it? Just curious. How is it when it's graphing? Comes to graphing, is it easy or? Okay. You just put it where the stuff is. All right. So I want you to see something. I'm about to. I can do this. You can't. So does that make a little bit more sense? Do you see how I shaded, covered up what it really wasn't there? And then you can really clearly see how things are. Now, I highly recommend colored pencils or colored pens. I really do. And if you notice, if I'm working something, I'm switching colors. Why? Huh? What?
You see the different steps.
Easier to differentiate the process through the solving method, right? I can call out specific steps and it draws your eyes to it as opposed to just it all being one color. So, all right. So there. That's how you graph it. Now, seriously, if I had to graph it on the computer, I don't know if I could. I'd have to graph it on here first on a piece of paper and then transfer it to the computer. Because I'd have little squiggly lines like that. All right. Questions? Yeah, I can. Wait, what does it ask? Oh, state the domain. Oh. What would be the domain on this one? Just curious. Since it asked, it would be what? Wouldn't it be that? There's an asymptote there. It doesn't exist at -3, right? Wouldn't that be the domain? There's my union, right? It's a whoppy jaw infinity, isn't it? There you go. All right. Y'all good? Yeah. You know how you get good at piecewise functions? You practice them, but you got to be good on the functions that they implement or that they use within them. If you're comfortable with linear equations, then it's not going to be any problem, right? But it just depends on if you're comfortable with that. Because have we graphed linear equations yet? No. So anyway, ready? All right, this should be the last one in this section, right? Man. Okay, so given what I have told you thus far, could you pick, if we say this and, oh, shoot. If this one's A, that one's B, that one's C, and this one's D, could you pick what graph goes with the piecewise that's there? You already know it. It'll get you 30, 45 seconds. Yeah or nay? Yeah, okay. All right, look at it, because this is really good to end on. For the answer is A. Can I explain why? All right, so the domain for this one is only for the first equation is between -1 and 2, right? But it has to be closed dots between -1 and 2. -1 has to have closed dot, 2 has to have closed dot, right? So A has it, B has open dots, right? And C has a closed dot, but an open dot on 2, right? But D has 2 closed dots. Hey, that's okay. So D and A right now, right? For -1, that's a horizontal line at -1, right? 2 is an open, 4 is a closed. So A has it, but does D have it? No, it does it too, but look at 4. 4 is open down here, right? So therefore, it disqualifies D. Right here.
So if it has the 4 equal to under it means it's closed, right?
Uh-oh. Dang it. Right there. If it's got the equal to underneath, then it's closed. And really, you're just looking at beginning and the end on those, right? You got to worry about it. Yeah. Okay.